All right, so we're going to keep working on examples of just the different types of angle relationships. We're not necessarily writing them in a complete sentence. You can if you really want to. But we're going to talk about these angle relationships and how we can use them by setting up equations. So when we look at this one here, notice we have this curve right here. Okay, that means this whole thing is 204. This is 90 right there because I see a little box, right? This is 5x and this is x. So honestly, I know all the angle measures that create a circle, and I know that totally doesn't look like a circle, but hopefully you catch my drift. So I'm going to add them all up. So I'm going to start here with the x. So I'm going to have 1x plus 90 plus 5x plus 204. That's angles around a point, this point right here. And that takes me back to the start, which means that's 360 degrees, angles around a point, going all the way around. Now I'm going to simplify and solve. If I have 1x's and 5x's, that's 6x's, plus 90 and 204 are like terms, so I'm going to add those together and get 294, and that equals 360. Okay, now let's solve for x. Since I'm solving for x, I need to get rid of whatever's being added to or subtracted from it. So I'm going to get rid of the 294 by subtracting 294. Whatever I do to one side, I have to do to the other. Bring down my 6x equals, and you subtract that, you get 66. Okay, now this is 6 times x, and I want to solve for x, so I'm going to divide. Whatever I do to one side, I do the other, and I get x equals 11. Awesome. One piece of advice though, make sure you're answering the question being asked. Find the measure of BAC. I did that. The measure of angle BAC is x, which is 11. Okay? And DAE. Well, DAE is 5x. So the measure, that's all the little m means, of DAE is 5 times x. So 5 times 11, which is 55 degrees. Okay, so again, the more you work with the stuff, the easier it's going to get, the more you're going to be able to see. So just keep persevering through it. All right, let's look at another example. Okay, lines AB and EF meet at a point. AB and EF meet at a point. Well, AB, EF, you know what? They meet right there. Okay, skipping this part. Set up and solve an equation to find the value of x. All right, so we need to kind of figure out what everything is, okay? So here's a 5x, here's an x. I don't know. I know this is 90, and I know this is 42. Okay, so again, not scribbling things out like I'm about to. My vertical angles don't necessarily help me out. I guess they could to a certain extent. I'm going to do it this way. Remember, after vertical, we look for corresponding. Nope. Supplementary. Okay? Add to 180. Angles on a line. This is angles on a line. So you can see that this angle, and this angle, those three make a straight line. If they make a straight line, that means it's 180 degrees. So I can say that if I add these together, 42 plus 90, this is 90 degrees, that gives me 132. And if I go 180 minus 132, I get 48. So this is 48 degrees. All right, so now I know this is 90, this is 42, this is 48. Now, when you darken these lines again, if this is 48, opposite it, this right here has to also be 48. Okay, now this is not the only way to do it, but you can see that we have 48, 5x, x, 48, 90, and 42. I want to set up and solve an equation to find the value of x. Okay. I could add all of them up and set it equal to 360. Or I could just kind of focus above the line here and know that these three angles equals 180. Either way, you're going to come up with the same answer. I'm just going to go 5x plus 48 equals 180 because it's a straight line. I'm going to write x is 1x Now, again, you could go plus 90 plus 42 plus 48 equals 360. We'll still get the same answer. If I have 5 x's and 1 x's, that's 6 x's, plus 48 equals 180. Solving for x, I'm going to get rid of what's being added on first, so I'm going to subtract 48 from each side. I have 6x, that adds to 0, equals 32. This is 6 times x, so I undo that by dividing. And we get x, and that's a 6 there, equals, I'm sorry, this is 132. My bad, that's what happens when we rush, right? 180 minus 48 is 132. When you divide that, you get 22. Awesome. Okay, make sure we're answering the question being asked. Set up and solve an equation to find the value of x. Check. Find the measurements of D, H, ooh, that's bad, D, H, F. That's just x. So the measure, let's move that down here. The measure of angle D, H, F is just x, and x is 22. The measure of angle AHD, AHD is 5x. Oh, just like before. We're going to go 5 times 22 and get 110 degrees. All right, so you guys can kind of see they're pretty much doing the same thing over and over. We just need to find those angle relationships. Last problem. 2 lines meet at a point. This should hopefully start looking familiar, because these are the ones I keep talking about. Set up and solve an equation to find the value of x. So when 2 lines meet at a point, we know that the opposite angles, the vertical angles are equal. So that's 3x equals x plus 30. All right, so now we have x's on both sides. So pay attention to how we solve this, okay? I don't want the x on the right side. I want all my x on the left side. So since there's 1x here, I'm going to subtract 1x. And then I'm going to come to the other side of my equal sign here, and I'm going to subtract 1x. And I'm going to be left with 2x's equal, that's 0, 30. Now you can say 2 times what number equals 30? Or we can undo the multiplication with division. 2 divided by 2 is 1, 1x. 30 divided by 2 is 15. All right, make sure we're answering the question being asked. Set up and solve an equation to find the value of x. Check. Find the measurements of one of the vertical angles. How about only one? Because they're equal. So this one over here would just be 3 times what x is, so 3 times 15, which is 45. And guess what? If you pick this one, you would get 15 plus 30. And guess what 15 plus 30 is? 45. Okay, that's why you only have to find one. All right, so don't panic if you see variables on both sides. Just subtract them off one of the sides so they can all be together on one side, and then just solving an equation like normal.